My dear students, welcome to the series on mathematics. Today we are going to look at the binomial probability distribution. If you're in grade 13, studying maths at A-level, as a main subject, you would be studying binomial probability distribution. Let me start by asking, can you think of a trial? A trial is an action, by the way, that will have two possible outcomes. For example, tossing a coin, you obtain either a head or a tail. As you know, in mathematics, we never take a coin to be vertical. So, when you toss a coin, either you obtain a head or a tail. Now, if you test an electronic chip, imagine you're an engineer, you are actually working in a manufacturing industry, and your task is to check whether the electronic chip is good or not. Of course, are you going to buy a chip which is not so good? You're unlikely to buy a chip which is not so good. You would buy a chip which is good. So, either the chip is good or it is faulty. Such type of actions or trials have been referred to as the Bernoulli trial, after the mathematician James Bernoulli. So, these trials have two possible outcomes. Now, if I throw a die, will I have two possible outcomes? Imagine you are playing, as I know you are at home, you must be playing a lot of games using die. If you throw a die, what can happen? A die can show you 1, 2, 3, 4, 5, and then 6. Do you have two possible outcomes? No. When you throw a die, you have 6 possible outcomes. But remember, when you are playing snake and ladders to start the game, what do you need? Or when you are playing Ludo, for that matter, to start the game, what do you need? You need 6. So here, we can actually group the outcomes into 2. We can group them into 2. So, for some trials, the outcome naturally are grouped into 2, like tossing a coin, testing an electronic chip. For others, we can actually form the 2 groups. Now, Bernoulli decided to call the 2 outcomes success and failure. You should not be taking this literally. Imagine the engineer who is actually verifying the electronic chips. What is he looking for? Is he looking for good chip coming out of the manufacturing chain? Or is he looking for faulty chips? The answer is very clear. In the manufacturing place, the chips are supposed to be manufactured properly. The chips are supposed to be good. So he is actually looking for faulty chips. So for him or her, the engineer, success would be finding a faulty chip. So for the engineer, testing an electronic chip, success would be finding an finding a faulty chip, and failure would be finding a good chip. Imagine you are going to play Ludo. What is success for you to start the game? Obtaining a 6 on the die. The rest would be failure because you won't be able to start the game. So, success and failure. For that matter, he could have called it apple and orange, but he decided to call it success and failure. Now, the probability of success is P. So, probability of obtaining a success in a trial is P. Probability of obtaining a failure is denoted by Q. Probability of obtaining a failure in a trial is Q. Of course, what happens? P plus Q would be equal to 1. P plus Q is equal to 1. Because there are only two outcomes, and therefore the sum of the probabilities will be equal to 1. Now, suppose that we repeat the trial n times. We repeat the trial n times. And let us make the following assumptions. First, each trial has only two outcomes. Second, probability of obtaining a success in one trial is same for all trials. Third, the trials are independent. Fourth, the total number of trials is fixed. And in this case, we call it n. The total number of trials is fixed. Let me take an example, because very often you might be asked by the examiner to illustrate how these assumptions actually hold in a particular context. Imagine you have someone who has 10 hens, right? How many hens? 10 hens. And he's interested in knowing whether a hen is going to lay egg or not. So, what is the first assumption? There are two things that can happen. Either the hen lays egg or does not lay egg. So we have only two outcomes here. Either the hen lays egg or does not lay egg. Probability of obtaining a success in one trial is same for all trials. What are we saying? We're saying that the probability that a hen lays egg is 70%, that is, we are 70% sure that a hen will lay egg, then the probability that any hen will lay egg would be 70%. So the probability of success is same for all trials. The trials are independent. That is, the hens don't unionize, don't talk to each other before laying eggs. So the trials are independent. And the total number of trials is already fixed. You can't have neighbor's hand coming to your place. So the total number of trials is fixed. So these are the assumptions. Now, if you throw the die twice, you would like to know how many times can I obtain a 6. If you throw a die 10 times, you would like to know how many times you would get a 6. So here, what are we interested in? If I repeat a trial 10 times, I would like you to do that experiment at home after you have watched the video. Take a coin and toss it 10 times, right? How many times would you expect to get a head? How many heads do you think you can get if you toss a coin 10 times? Let's take an example. Toss a fair coin 10 times. We toss a fair coin 10 times. Let us define X as number of heads obtained. Number of heads obtained. How many heads are you likely to obtain? Let's think about it. You have the coin in your hand. You toss it 10 times. If you have other coins, give it to mommy, daddy, anyone sitting next to you. Ask them to toss it 10 times each. What can happen? 0. This is one possibility. That you toss the coin 10 times and you never got any head. You got 1 head. What does that mean, X equal to 1? You toss the coin 10 times, you got only 1 head, which means 9 times you got tail. X equal to 2. What does that mean? 2 times you obtain head, and 8 times you had obtained tail. 3, 4, 5, 6, 7, 8, 9, 10. What does X equal to 10 means? All the 10 times you managed to obtain a head. What does X equal to 9 mean? 9 times you obtain a head and 1 time you obtain a tail. So, X can take any value from these 11 values. Does it make sense to say X equal to 11? Can X be 11? Of course no, because you have tossed it 10 times. If you have tossed a coin 10 times, can you get 11 heads? No. Can X be 3.7? Can you say, well, I tossed the coin 10 times and 3.7 times I got a head? No. So, X can take any of these 11 values. Therefore, this is a set of exhaustive values. So, probability X equal to 0 plus probability X equal to 1 up to probability X equal to 10 will be equal to 1. Now, in general, if we repeat the trial n times, probability X equal to 0, X equal to 1, will give us 1. Very useful to remember this. Now, how do I calculate each probability? How to calculate probability X equal to R? NCR P power R, Q power N minus R. So I'm going to take it in the next slide. Probability X equal to R is equal to NCR, P power R, Q, N minus R. Looks familiar, isn't it? It looks like the binomial term that you have learned previously. Now, when we repeat a trial several times, we obtain an experiment. And when we repeat the Bernoulli trial several times, we obtain what we call a binomial experiment. That's why we call this the binomial probability distribution. Remember, X takes values 0, 1, 2, 3, up to n. X equal to 2 means I have 2 successors and the remaining are failures. If I ask you to calculate probability X less than or equal to 2, does this mean 0.5? X less than or equal to 2 in this case, does it imply X will be equal to 0.5? No. What does that mean? X equal to 0, X equal to 1, X equal to 2. If I had X is strictly less than 2, then it means X equal to 0 plus X equal to 1 only. 2 is not included. Very often, we use the property that the sum of the probabilities is equal to 1. If I ask you to calculate probability X greater than 2, what does that mean, greater than 2? Does greater than 2 means 2.5, 2.7? No. In this case, greater than 2 would mean what? X equal to 3, 4, 5, 6, 7, up to n. So X equal to 3, X equal to 4, X equal to 5, X equal to n. So that's the useful way of calculating the probability. So I have too many probabilities to calculate. One way to do it easily would be to use the property that I have taken all values except 0, 1, and 2. So this can be 1 minus probability X equal to 0, X equal to 1, X equal to 2. So instead of calculating so many probabilities, here I just have to calculate only 3 probabilities. So probability X greater than 2 is 1 minus probability X equal to 0 plus X equal to 1, X equal to 2. So in this way, I reduce the number of probabilities I have to calculate. That is the number of times I have to use this formula. So remember, what is X? X is the number of successes that I obtain when the trial is repeated n times. X equal to 3 means we have obtained 3 successes. Now, what is the expected number of successes? NP. What is the variance of the number of successors? NPQ. So, how many success do you expect n times p? And how do you expect the variance of the number of successes to be? It's npq. How will it vary, the number of successes? How will the number of successes, that is x, vary? So the variance is calculated using the formula npq. So what we have seen till now is that a Bernoulli trial is a trial that has only two possible outcomes that we call success and failure, that we should not take literally. If we repeat that trial n times, we would like to know how many successes we are going to obtain. There are 4 assumptions that we make in order to be able to calculate that probability. First, the trial must have only 2 possible outcomes. Second, probability of obtaining a success in one trial must be the same for all trials. The trials must be independent of each other. And fourth, the total number of trials must be fixed. This is the formula to calculate the number of successes, probability of number of successes. If R is 2, I'm going to calculate probability x equal to 2. What is the probability of obtaining only 2 successes? nc2, p power 2, q power n minus 2. And in general, the expected number of successes is np and the variance is npq. We are going to illustrate that using an example now. Let's take the following example. The probability that a chip, an electronic chip, is faulty is 0.35. If I say 7 chips, of course electronic chips are chosen randomly. What is the probability that two chips will be faulty? More than 2 chips will be faulty. Out of 100 electronic chips manufactured, how many chips you expect to be faulty? Now, let's see whether we can apply a binomial probability distribution here. Remember, an electronic chip can either be good or faulty. There is no in between. Either it is good or it is faulty. So the trial has 2 possible outcomes. What are the assumptions we have to make? That the chips are manufactured independently of each other. That's the assumption. The probability that a chip is faulty is 0.35, and it remains 0.35 for all manufactured electronic chips. So the assumptions seems valid here. So we can use a binomial probability distribution. How will I define X here? How will I define X here? Number of faulty chips, faulty electronic chips among the 7. Remember, we have 7 electronic chips that are chosen randomly. What's the probability that 2 chips will be faulty? If you have 7 electronic chips, right, to test, imagine you are the engineer, you are testing the 7 electronic chips. How many chips do you think you will find that will be faulty? Maybe 0. All of them are good. So they have been well manufactured. Or it can be what? It can be 1. Can be 2. Can be 3, 4, 5, 6, 7. Can it be 8? No, because you only had 7 electronic chips. Can it be 3.5? No, because either chip is good or it is faulty. So, X can take any one of these 8 values. What have we been asked? We have been asked to calculate the probability that 2 chips will be faulty. So, number of, remember here, this is a success. Obtaining a faulty chip is a success. Obtaining a good chip is a failure. And what is the probability? The probability of success has been given as 0.35. And here, therefore, the failure will be 0.65. Why it will be 0.65? Because P plus Q is equal to 1. Now, how do I calculate probability X equal to 2? I use the formula. And what is N in our case? 7. So it will be 7. How many successes we are looking for? 2. So we had 7 in total, and we are looking for 2 successes. What is P? 0.35 power 2. What is Q? 0.65. So P is 0.35, R is 2. Q is 0.65. What is N here? 7 minus 2. So we have applied the formula. N is what? 7. C, 2. Because we are looking for 2 successes. What is P? 0.35. We are looking for 2 successes. Q, 0.65, 7 minus 2. So, you use your calculator to calculate that, and ensure that you get 0.298. 0.298. Now we're going to look at the second part. What does the second part ask us to do? Find the probability that more than 2 chips will be faulty. More than 2 chips will be faulty. We are asked to find probability that more than 2 electronic chips are faulty. So, I write it in terms of x. X is greater than 2. What does greater than 2 mean? Does it mean 2.3? Does it mean 3.4? No. Greater than 2, we have said that x can only take 0, or 1, or 2, or 3, or 4, or 5, or 6, or 7. So this means what? X can be 3, 04, 05, 06, 07. Now, you remember I said earlier, instead of calculating all these probabilities, it's better, we say, 1 minus, what are the values of x that we have not taken? 0, 1, 2. So, here, I have not taken 0, 1, and 2. So 1 minus. So I'll let you do this calculation, right, at your own place, at your own pace. Next part. It says that if you had 100 electronic chips, how many chips would you expect to be faulty? Now, the number of chips that we would expect to be faulty, x say number of faulty chips out of 100. How many faulty chips can you get out of 100? 0, 1, 2, 3, 4, 5, 100. Now, another way to write it is that x follows a binomial. B is for binomial probability distribution. This is the symbol for follows. N, what is n here? 100. And what is the probability of success here? We said probability of success is 0.35. And we had earlier said what is the expected, the formula for expectation, expected number of faulty chips is NP, 100 times 35. So the expected number of faulty chips will be 35. So let me summarize the binomial probability distribution for you. We said that you must have a Bernoulli trial which is repeated n times. There are 4 assumptions. Each trial must have only 2 outcomes, success and failure. P is the probability of success. And therefore, Q is the probability of failure, which is given by 1 minus P. X is the number of successes obtained when trial is repeated n times. X can take value 0, 1, 2, 3, 4. 4 assumptions. Each trial has only 2 possible outcomes. Trials are independent. Probability of success in one trial is same for all trials, and total number of trials is fixed. If the 4 assumptions are valid, then X is said to follow a binomial probability distribution. How do I calculate X equal to 2, 3, X equal to R? The formula is NCR, P power R, Q power N minus R. So, this is the formula to calculate probability. X equal to 2 means I have obtained 2 successors and the remaining would be failures. What will be the expected number of successors? N times P. What will be the variance of the number of successors? N times P times Q. So, My dear students, this brings us to the end of the lesson on binomial probability distribution. As you have seen, we have discussed what is a Bernoulli trial. When the Bernoulli trial is repeated n times, you have a binomial probability distribution. There are 4 assumptions. If the 4 assumptions are valid, then we can use the formula to calculate the probability. We also had another formula to calculate the expected number of successors as well as the variance. As you know, in your syllabus, you also have that part where we use a normal probability distribution to approximate a binomial. We are going to discuss that later on in another program. So, till then, it's goodbye from us.